Hello and welcome back for another session of Streaming School. Now, as we did last Friday, just to top off, one of my dear friends, Sheila Bala, is going to deliver a pre-recorded lesson. So this lesson is not live like every other lesson is. The only reason we do this one here is because with the maths, sometimes we're offering different levels. So this is the only time or the only way that we can currently get high level maths at this time on Friday. But of course, the situation is with everything. It's very fluid and it might be changing in time. So I'm going to be sharing my screen, which is playing a video for you, but just like everything else, it's still going to have an activity at the end. So please enjoy. And we do have a lot of, I think we've got 4,000 recorded lessons, and we're just going to work out the best way to support schools in putting them on, but the focus for us is really to be live during this time. So, you know, when people start interacting, there's going to be people there for them. So please do enjoy the following video. It's not live, but in the future, we will be turning them into live lessons as well. Many thanks.
Good morning, everyone. I hope our first lesson on factors was very useful. Today, we're going to do the second part of the lesson. So we're going to finish off by doing a little bit more on lowest common multiple and then going into some exam questions. So just to recap, let's go back to the PowerPoint and have a look at what we discussed last lesson. So here you can see the first thing we remember, if you remember, we did was the product of prime factors, right? Then we worked out how to find the highest common factor of two numbers. And then we worked out a way to find the lowest common multiple of two numbers. Now, the reason I haven't ticked the third thing is that actually there's an extra step to it. You can also use both methods to try and find the lowest common multiple of three numbers. And sometimes this does come up in your exams, especially as a worded question. So let's go straight into it, okay? So let's have a look at this. Before we do the three-way thing, let's just recap how to do the division method with two different numbers. So here you've got 150 and 120, and you have to find the highest common factor and the lowest common multiple of those two numbers. So first thing, if you remember, I'm going to do is divide both numbers by a common factor. I can see they both end in 10 with 0, which means I can divide by 10. So first number is a 15, and the second number is a 12. Now I'm not done that because I can also see here that 15 and 12 are both divisible by the number 3. So we're going to write a 3 here. And here you get the number 5, and here you get the number 4. Now we are done because there's nothing else that can divide into both those numbers. Now, if you remember, to find the highest common factor, you had to multiply those two numbers together. So the highest common factor here is basically 10 times by 3, which is 30. Okay? But to work out the lowest common multiple, you needed to multiply together these two numbers and those two numbers. It's like the letter L, as in lowest common multiple. So to work out the LCM here, what you have to do is 10 times 3 times by 5 times by 4, which is the same as 30 times by 20, which gives you 600. Okay, so in this particular question, the highest common factor is 30, and the lowest common multiple is 300. Okay, so let's now go on to the next level. That's a little quick recap of it. Let's have a look at the next level, which is talking about the lowest common multiple of three different numbers. Now, I'm going to do this once using the factor tree, just to give you an example. Okay, just once using the factor tree, but I do still prefer the division method. So I will do the same three numbers with the division method, so you can compare and see why I prefer the division method, or decide that you prefer the factor tree. Whatever works for you, to be honest, okay? So with 36, I'm going to divide it straight into 6 and 6. Now this bit you should be able to do quite quickly now. So 6 and 6. And then you know that 6 breaks down into 2 and 3, and 2 and 3. So I'm going to write those two numbers instead. So 2 here, 3 there, 2 there, and 3 there. Okay, so those are the four numbers I gave for that. For the number 30, okay, for the number 30, I'm going to break those down into its numbers. So I'm going to realize that here, 30, because of the 0, I automatically think of 3 and 10. Okay, actually, I'm going to change this into two different colors, so hopefully it helps you later on. 30, I'm going to break it down to 3 and 10. Okay, so there's a 3 there. Oh, that's not really doing back, is it now? There we go, 3 there, and a 10 there. Okay, and then I'm going to break those numbers. The 3 is fine, it's prime already, but the 10 I'm going to break down into the number 2 and the number 5. So there's a 2 there, and there's a 5 there, and that's it. Okay, so that's those are prime factorizations of that number 30. There's no more that I need to do. Okay, and then the very last one over here, 60, I'm going to break that down into its two numbers. And again, I'm going to use the 6 and the 10 because I know those come from the 60 very easily. And from here, I'm going to break those down further into 2 and 3 and 2 and 5. Okay, so that's 2 here, a 3 here, a 2 here, and then a 5 here. Now, because there's 3 numbers instead of 2, if you remember prime factorization, we did it with 2 circles, right? So now using 3 things, now that you've got the 3 things, you've got to do a Venn diagram in 3 sections. So I'm going to try and do this so you can understand it better using the colors that we have. So for the number 36, I'm going to draw a blue circle. Okay, so everything in the blue circle comes from the number 30. 36. The number 30, I'm going to draw in green. And then the number 60, I'm going to draw in red. Okay, so you can compare and like understand. Hopefully it'll be a little easier to identify where each number lies. Okay, so let's have a look at this now. Okay, if you notice here, you look for a common number in all 3. Can you see the number 2 is in every single number? So across them out of all of them, and again, just like before, you pop it right into the middle. Okay, so you put the number 2 there. If you look again, can you see any other numbers that's in all 3? The number 3, right? So again, I'm going to cross out the number 3 here, cross out the number 3 here, and cross out the number 3 here. And once again, write that number in the middle there. After that, now what I'm going to do is, can you see these little sections here, these 3 sections here? They're for numbers that are mutually between these 2, or between these 2, or between those 2. They're not numbers that appear in all 3. So if you look between the 36 and the 30, can you see they both have, do they have any numbers? I don't think they do actually. So there's no numbers that they have in common here. Looking at the 30 and the 60, I can see there's a 5 in both. So what I'm going to do is delete the 5 from here and delete the 5 from here. And I'm going to put that in the area that combines the green and the red. So that 5 goes into that spot there. Then I'm going to look again at 36 and 16. Can you see the blue? That 2 is in both of the numbers. So again, I'm going to cross out this 2 and this 2, and I'm going to put it in the area that overlaps the blue and the red, which is just down there. And finally, I look for any numbers that are on their own. And the blue has a number 3 on the outside, which means there's a 3 out here. So once again, the highest common factor, which is not what this question is asking for, but if you wanted the highest common factor, it'd be the 2 numbers here multiplied together, the 2 times the 3. So the highest common factor of these 3 numbers is 6. Okay, but that's not what we're asking for here. We're asking here for the highest common, the lowest common multiple. So to do the lowest common multiple, you can multiply all the numbers that you see together. So you do 3 times 2 times, so 3 times 3 times 2 times 2 times 5. You've got a calculator, you can do it however you want. So 3 times 3 times 2 times 2 times 5 gives you 100. So that is the lowest common multiple, the lowest number that all 3 numbers divide into. Okay, so that's not bad, I'm hoping. It's a little complicated because of the 3-way diagram, and I'm not too keen on using a Venn diagram that's so complicated. So what I'm going to do for you now is show you what it would look like if we did it using the division method. Okay, so I'm going to get rid of this. I'm going to have a look at the next page, which is the division method. Right? So it's exactly the same numbers. What I'm going to do is division method. Now dividing, just like before, if you're on division, you divide by a number that you can see in all 3. And I'm sort of cheating because I remember it from the question before, like the example we just did, but I know the number 6 divides into all those 3. So I'm going to divide that by 6, which gives me 6. Divide that by 6 gives me 5, and divide that by 6 gives me 10. Now here we get to a situation where none of the numbers, no number divides into all 3, but that's okay. All you have to look for is a number that divides into 2, at least 2 of these numbers. So if you look at the 6 and the 5, nothing's going to divide into those 2, but the 6 and the 10, yeah, I can see the number 2 divides into those. So I'm going to divide just those 2 numbers by the number 2. Divide that by 2 becomes a 3. You copy the 5 down because you haven't done anything to it yet. And then that becomes the number 5. And then you look again. You try and think, is there a number that divides into at least 2 of these? And if you look, there's a 5 and a 5. That means that you can divide at least those 2 numbers by the number 5. You've got the number 5 here. Here you keep the number 3 in. Here it becomes a 1, and there it becomes a 1. And this is where you stop again. And the reason you stop here is because you can't divide even, you can divide by 1, but it doesn't make a difference. We don't divide by 1 at all. You only try and think of numbers that are higher. So basically here is where you stop. Just like before, here, just like before, you use the letter L to work out the lowest common multiple. So here, the lowest common multiple is those 3 numbers multiplied by those 3 numbers. So once again, the lowest common multiple here is 6 times 2 times 5 times 3 You don't usually do times one by one because obviously that makes sense. And if you did that again, that's 30 times by 6. So that's also 180, which is the same answer as you got before. Now, one thing I really want to point out to you, you can only do these two numbers now because you know you're looking for the highest common factor. If you're looking for the lowest common multiple, forgive me, here you can only do those two numbers because you're looking for the lowest common multiple. If you're looking for the highest common factor, it's still the number 6 because it's the only number that can divide into all three. So don't get confused and multiply all these three together to get the highest common factor. The highest common factor is just that number 6. Okay? Right. So I know that's a lot to take in, but what I'm going to do is I'm going to let you guys have a go at the next question, which is another three-way question. Have a look at this. Pick whichever method you prefer. I'll give you a little while to try it, and I'm going to have a go at it using the division method once you've had a go at this yourself. Okay? Have a go. Let me know how you go. So remember, if you're doing the division method, you've got to think of a number that divides into all three first of all. Okay, just a few more seconds. I understand that some of you are probably still finishing. I'm going to still start my answer to this question just so you can see that you're on the right track. Okay? So I noticed in all these three numbers that the number 7 divides into all of them. So this becomes 20, this becomes 30, and this is a number 6. Okay? And then I can still see that they're all even numbers. So I'm going to divide now by the number 2. I divide by the number 2, I get the number 10 here. I get the number 15 here. And I get the number 3 here. So this is where I'd stop. If I was asked for the highest common factor, I'd say the answer is 14. But we're asking for the lowest common multiple. So here you get to keep going. We're going to divide all those three numbers now by something that can go into all three. Actually, you can't. So you're going to look for a number that divides into at least 2 of them. So the first I see, the number 5 goes into both. Okay, so I'm going to put the number 5 in. Divide this by 5, I get 2. Divide this by 5, I get 3. And this remains the number 3 because I haven't divided by it, right? And then now you're going to divide those three numbers, if you can, by another number. And if you look at them, the 2 can't work, but the 3 and the 3 do divide by the number 3. So I'm going to put the number 3 here. This stays as the number 2. This becomes the number 1, and this becomes the number 1. And again, once you get to this point, you realize you cannot divide by anything else. So you stop. And the lowest common multiple is the multiplication of these 4 numbers and these 3 numbers. So your lowest common multiple is now 7 times 2 times 5 times 3 times 2. Again, you put in the calculator, you can do it yourself. Okay, and obviously very quick ways of doing it by yourself as well, which I'll just talk about now. The answer is 420 for this particular question. A quick way of doing it, if you wanted to, would be to realize that, let's say 5 times 2 is 10. Then I would do 3 times 6, which is 3 times 2, which is 6, times by 7, which is 42, and then 42 times 10 gives you 420. So this could come up in a non-calculated paper very easily. Okay, I hope you understand that. What we're going to do now for the last few minutes of the lesson is have a look at some exam questions where this in particular is applied. Okay, so these exam questions are not your bog standard ones where they just ask you to find lowest common multiple or highest common factor. They're worded questions. So let's have a look at this question here. I'm going to give you just 20 seconds to have a quick read before I start talking. Okay, so the idea is to find the time at which they lapse together and they finish the cycle at the same time. So one's going at 50, the other one's going at 80, which is a little slower, and eventually they meet at the same point. So what they're really asking for here is the lowest common multiple. So we're going to divide both numbers by something you can see that goes into both. And here it's obviously number 10 because they both end in 0. You get the number 5 here, and then you get the number 8 here. And if you check, even though they're not prime, neither one, like they can't be divided by the same number. So we just stop there. That's the end of the calculation, which is quite nice actually. So now we look for the highest common factor, lowest common multiple. The lowest common multiple, the LCM, is 10 times by 5 times by 8, which is 10 times 40, so that's 400. So it's 400 seconds since like by the time they'll cross over with each other. Okay, so how many laps will they each have cycled by the time that they next start together? So it's 400 seconds. Now, the thing you need to understand here is that the 400 seconds has to be divided by how long it takes for each person to work out how many laps it is. So for Matt, he takes 50 seconds per lap. So you're going to do 400 divided by 50. I tend to do it like this because it's quite easy to cancel. So you can cancel out the zeros, and then you can go 40 divided by 5 is 8. So you know that for Matt, he's done 8 laps by the time they overlap again and they start at the same time. For the second person, for Dan, you have to do 400, but now you must divide by his number. So he takes 80 seconds per lap. So I'm going to divide that by 80. And again, cross out the zeros. That's why it's good to write it as a fraction. It's nice and simple. Cross out the zeros. And then how many 8s go into 40? And the answer is 5. So you know that Dan does 5 laps. That exam question is worth 3 marks, okay? I hope that makes sense to you. So it's like 2 different sections. Find the lowest common multiple and then divide through to find out the number of laps. Okay? Right, we're going to have a look at another question now. Okay, let's have a look at this one. Let me clear this so we can try this one. Have a quick read through this and have a go at this one by yourself. I'm going to give you a couple of minutes and then I'm going to start it as well. So if you've chosen to do this question in the factor tree way, it's not that bad actually, because obviously it's 2 numbers. You can still do the 2-way Venn diagram and find the lowest common multiple. Here, once again, you have to find the lowest common multiple because you want to know when they would leave the bus station at the same time again. So, but remember, there's a very important thing with the 9 a.m. here as well, for later on. So first I'm going to divide both numbers by 4. So you can see that's the biggest number I can think of that goes into both. And I get a 6 and a 5. And once again, you can't do anything with the 6 and the 5 because nothing divides into those 2. So now you can work out the highest common factor here. So the highest common factor, the lowest common multiple. The lowest common multiple here is 4 times 6 times 5, which is 30 times by 4. That gives you 120. So it's 120 20 minutes here. Okay, so it's 120 minutes. Now, if you notice, the question is talking about 9 a.m. So obviously it's talking about, hours and minutes. So I can actually change that to 120 minutes into 2 hours by dividing by 60. So it takes them 2 hours to do their whole little route and then leave at the bus station at the same time. So if they start at 9 a.m., by the time they cross over each other's paths again, it'll be 11 a.m. So down here, you write down a.m. to make sure you get it. And again, that question is worth 3 marks as well, because there's 2 different stages. One is the lowest common multiple, and the second part is working out what to do with that question at the end. Okay, I hope that makes sense to you. Hope you understand that. Great. Okay, so let's have a look at the last question that I've got here for you. Let me see. Yeah, let's have a look at this one. I'm going to let you do this one. I'm just going to give you the answer for this one, okay? So I'm going to give you just 30 seconds, maybe a minute to have a go at it, and then we'll answer it together. Okay, so just like in the question before, you've got 20 cheese slices. This is actually quite a realistic question because I'm sure this happens to a lot of people as adults when they're buying things, even kids, when you're going out and buying something and trying to work out how to make these things overlap and have the right number of each thing, right? So here, cheese slices and burgers, what more could you ask for? So in this question, we're going to find out what common factor goes into both. And again, here I can see that the number 4 divides into both. That becomes a 5. And that becomes a 3. It's nice if you can spot the biggest number, but if you did 2 and 2, it wouldn't make a difference. Here you stop again because 5 and 3 cannot be divided by anything else. And then your lowest common multiple, and then your lowest common multiple here would be the multiplication of these numbers. So 4 times 5 times 3, which is 20 times 3, which gives you 60. That means there are 60 different things, like 60 pieces of cheese and 60 pieces of burgers that you'll need to make this up. So when you're working out the packets, once again, you've got to do what we did with the time thing. There are 20 cheese slices and you know you'll make 60. So to work that out, you'll have to do 60 divided by 20 to work out how many cheese slices you'll need. And that's what the question's asking. They don't care about burgers. They use the cheese slices, 60 divided by 20, cross out the zeros if you need to, and 6 divided by 2 is the number 3. So here, there are 3 packets of cheese that need to be bought. Okay? Right, that's the end of today's lesson. However, I will provide you with a link to a couple of other questions that might be useful. Yeah.
Hey, thank you very much for the prompt, Nish. I was paying as much attention as I do in maths lessons when I used to have to sit them in school. Sorry, I got distracted with a million other things. So I will thank my friend for that, and there might be a few more recorded videos next week, just as people go back into schools and go back into their roles, and trying to fit around revised timetables within their establishment. But yeah, that will be all for us for this week. I hope you've enjoyed what we're doing. And Nish, do we have a presentation for this? Do we have an activity for this lesson?
Yeah, we do.
All right, brilliant. So I'll share to your screen, and I wish everyone a very good weekend.
Right, cool. So here is the optional task that Sheila mentioned. It is a link, and it will take you to a worksheet.
I like how you're trying to stretch that out while the worksheet loads.
Yep. With a few questions, very similar to the ones that she went through in the video. These will all be up on Facebook and YouTube. You can catch up on any videos there. I'll put the links on there as well. And there is another website here that if you join, there is an access code because it's super special. It's me123, and if you just log in, you'll be able to access all the videos that we've had previously, and the resources will be on there as well.
Wonderful. Thank you so much, Nice. And it's been another fun week covering all the bases. And I look forward to. I hope you have a brilliant weekend, and I hope to see you next week.